Yes, this one looks good.
Okay. So there's the way we're going to do with this problem. We're moving into what's called the chain rule. I think we did a little bit last week, but if this were 2e to the x, the derivative would be itself. E is the only function whose derivative is itself, but it's not. It's really 2e to the u, and u is this 4x plus 1. So the derivative is still 2e to the u, but you have to multiply by the derivative of u.
Okay.
And that is the chain rule. The chain rule is you have this extra little piece that you have to account for. The derivative of 4x plus 1 is 4. That's power rule on the x. Derivative of a constant is 0. And so what you do is you take your substitutions and you plug them back in. So
wouldn't it be, sorry, just with the 4x to the 1 plus 1, you said the derivative is 4. Is it not 4x? Like
it's
that
4x,
completely?
but then it's 1 minus 1 for the exponent. You always subtract 1. 1 minus 1 is 0. X to
Right.
the 0 is 1. So it's 4 times 1, which is just 4.
Gotcha. Okay, sorry.
And then the derivative of a constant is always 1. Or I'm sorry, the derivative of constant is always 0.
0. Okay.
Yeah. Okay. And so in terms of this chain rule, you just piece everything back together. So it's 2e to the 4x plus 1 times 4. And then you can simplify here. You can multiply the 4 and the 2. So it would be 8e 4x plus 1, like that.
Or x plus 1. 8e to the 4x plus 1. Perfect.
Yes. Okay, next question that I'm seeing, snip that in. Find the derivative of the function. It's a product. This is a product of x to the 6th and e to the x. So there is what's called a product rule derivative. Okay, and that is if you have two things, u times v multiplied together, and you want to take the derivative, that's what this prime means. It is u v prime plus v u prime. And in short, you take the derivative of each one separately. So we're going to let u equal x to the 6th and v equals e to the x, and we're going to take their derivatives separately. So e to the x to the 6th is 6x to the 5th. You're subtracting 1 from that exponent. E's derivative is itself. So the way this formula works, this is the product rule derivative. It's a well-known derivative. Is you pair them up. So the u is really x to the 6th. The v prime is e to the x. The v is e to the x, and the u prime is 6x to the 5th. So what I like, if we were in a traditional classroom, I would show you how you combine these diagonally, essentially. So the x to the 6th goes with the e to the x, and then plus the e to the x times 6x to the 5th. And just to kind of clean it up in terms of how you'd write it, we would go x to the 6th e to the x plus 6x to the 5th e to the x, just to kind of reorder it.
Okay. Yeah, that makes sense. Okay, give me just a sec.
Of course.
Okay, perfect.
All right, so next question. The first thing I want to point out here is that they're using z as the variable instead of x. If you don't like that, or if that, just because it's been a while, it's okay to change it back to x. Like that won't change the answer, but we do have to enter the answer in terms of z. But for us, it's probably good to leave it as x. So if this were if this were x to the sixth, you know how to take the derivative of that. Okay, we did it in the last problem here, but it's not. It's really u to the sixth, where u is this 8x plus e to the minus x squared.
Okay.
Okay, so let's treat it like that for now. So the derivative of u to the sixth is 6u to the fifth. That's the power rule. And then you multiply by the derivative of the inside function. Is that okay so far?
Almost. Are you kind of theoretically using u to the sixth?
Yeah,
Like
it's a substitution. It's a common practice in this course and the second semester of calculus to do this type of substitution. The chain rule is based on composition of functions, which I'm trying to avoid talking about, because it literally it is the composition of this u and this x over here, 8x plus e to the minus x squared. That is what we're doing, but I'm trying to hide that because it doesn't really matter what for us what we're doing
Okay.
today. So they're like there's this whole list of derivative rules, but they all have a chain rule, kind of like they're all really chain rule, but they're not presented that way. And I was trying to make this point last week, but like when you take the derivative of x cubed, the derivative is 3x squared. But if you were to take the derivative of the inside function, which is x, the derivative of x is 1. You're actually always using the chain rule. It's just that the derivative of x is 1, so it never adds to or combine, never really changes the derivative itself. But in the problem we're doing now, the inside function is more complicated. It's truly a function of x, so we have to take its derivative.
Okay.
So, on the right here, the derivative of 8x, whenever it's a number times x, the derivative is just 8. Okay. But this next part, we've got to kind of come off to the side here. You're in that engineering world, like think of these as like sub blocks. If you ever, someone throws up a block diagram, like we're now like drilling into that one, and then maybe that one has a couple of subsystems or sub blocks, and you got to keep drilling down into it.
Definitely.
So this e to the minus x squared, and this is awkward, but what we're going to do with that is we're going to treat it like e to the v now. I'm just using a different letter because we already got u going, where v is minus x squared.
Okay.
We're gonna come back. So we're working on this right here that I've circled, but we're working on it down here where it's a little different. The derivative of e to the v is itself times v prime. It's chain rule again, because v is really a function of x. Now we got to find v prime. V prime is minus 2x to the 1. And so now we back substitute. So our derivative is really e to the minus x squared times minus 2x. And all of this is what goes up in here. Okay, so just if I rearrange it, minus 2x e to the minus x squared. There's your derivative. And now we can go back and take the u that we calculated and put it in here. So we can take this u, put it in there, and then this u prime, put it in there.
Oh, okay.
And that's what I meant by like kind of the blocks and the subsystems and things like that. The other thing is it's really in terms of z. So we're going to do that now. So it's 6. This is finally the answer. 6, 8z plus e to the minus z squared to the power of 5. So that's taking care of the 6u to the 5th times, I'm going to use parentheses here, 8 minus 2z e to the minus z squared. That's the u prime. That's your final on that.
Okay. Eight minus 2z e negative z to the second.
If you need to send me a picture or screenshot, or you want to share your screen to confirm that you got it in right, that's I'm certainly willing to do that, to look at it.
Okay, let me double check here. That's crazy. Okay, I think we're good.
Awesome. They can get way more complicated than even that, but
Oh my.
yeah. It doesn't, it's just, it ends up being more of the same. It's not. So, okay. So before we do this problem, what we've been doing, like what you're used to in your life is X, I'll just use X squared, which is really a variable to a number. But there are also these functions that are a number to a variable. And instructors in like a traditional classroom course, they really like to throw these in at students, mix them up to really confuse them. The problem we have here is the second type. And you might say, well, hey, Matthew, there's more than a variable here. Yes, there's a full-on function, a line up there, but it's of this form. It's a number to a letter, number to a variable.
Mm-hmm.
So the rule for that is if you have y equals a to the u, and we're generally using u to represent it's a chain rule type of derivative. The derivative is itself times the natural log of a, which is the base, times u prime. This is just one of those rules. There's a list of 20 of these, we'll say, that
Okay.
are come up in this course. Okay. So you've got to like sort of match, like, okay, well, what do you have here? Your problem is y equals 5 to the u, where u is 8x plus 7. So your derivative y prime is 5 to the u. That's, I'm doing this part down here, the a to the u, times the natural log of 5, that base number, times u prime. Okay, so notice I have u, but I don't have u prime. I go ahead and calculate u prime. The derivative of 8x plus 7 is 8. And so now you're just backfilling. You're putting the values that you calculated back into the function here, into your derivative. So 5 to the 8x plus 7, natural log of 5 times 8.
Okay.
And in terms of entering this, it's probably easier to enter it this way: 8 natural log of 5, 5 to the power of 8x plus 7. That might be slightly easier. I think you can just type in ln in your box there.
Okay. Okay, got it.
So mostly the problems we've been doing today have been about recognizing the type. And once you recognize the type, you just apply the rule for the type. I mean, it sounds easy, but it really does take a while to get to where you're like, oh yeah, that's a quotient rule, like we're about to see in this.
No, I completely agree with that. And like that applies to like my entire life with math. Is like you can walk me through a problem and it makes sense. But when you give me a problem on my own, it's knowing that first step, right?
Yes.
So you'd obviously naturally have these rules, totally memorized. So what you're explaining makes sense, right? But
yeah, so on a much simpler level, and I've done some research on this. Let's say I wanted you to solve the problem x plus 4 equals 3.
mhm.
Sometimes students don't recognize that 4 plus x equals 3 is the exact same problem.
Mhm.
And that 3 equals x plus 4 is the same, and 3 equals 4 plus x is the same. So there's actually really interesting, like, love to get some more funding to like study like why we can't identify that these are actually all the same type of problem.
Mhm. Yeah.
Because it's just a variation on the same thing. But like you said, if it's like, I've never seen this before, it's like, no, you have, but it's slightly different. And who's right? I think, well, we're both kind of right. It is the same, but you haven't seen it before. How do we close that gap?
Yeah. Good point.
For that. So this is a product rule. I'm sorry, quotient rule, u over v prime. And so this is a v u prime minus u v prime over v squared. And that's the formula for the quotient rule.
Can I clarify something with you?
Of course.
We went over this last time, right? Like you were
Yes.
applying these rules.
Some of them. Yeah.
Some of them.
I don't know if I got to all of them. Yeah.
Okay. I feel like I definitely recognize this one. And the product rule as well. What of these questions was something new?
Maybe the chain rule, but I thought we did that last week.
Okay.
Maybe.
Yeah.
I'm looking up this table of derivatives that I usually send calculus students. Let me see if I can copy link and just throw it in the chat here.
Sure.
They make books of derivatives and integrals, which the integrals come later at the course. But you actually know the top half of this page, even though when you see it, it'll probably look like a foreign language. Because it did to me when I learned these many years ago. You actually know all of these rules, believe it or not. And quotient rule. We've talked about the product rule, chain rule. All of these in this polynomial section I call the power rule. I actually don't know if that's what it's really called, but I think that's what it is. So this is a core part of calculus, is knowing these rules and knowing when to apply them to what problems.
Okay.
And so there's everyone's got one. There's you got to find the one you like. Reference sheet, have it there while you're doing problems if you need to. So let's go back though. Because this is a quotient rule, you just apply the rule, but you do need to write out what u is. U is 9x to the 6th. V is natural log of x. And then you take the derivative of each separately, which you know how to do right now. It's 6 times 9, 54, x to the 5th. This natural log of x is a new one to you. That's 1 over x. So if you look at that, if you do open up that page I sent you, you don't have to do it now, but you will see that ln of x is down there, kind of towards the bottom for the rules here. And the reason we're not doing like x prime or u prime is because we've already done the u and the v stuff. We don't have to for here from here. All right, so now it's just a matter of like grouping them all together. And let me just move this down a little bit. So the rule is v u prime. So we've got natural log of x times 54x to the 5th minus 9x to the 6th times 1 over x all over natural log of x squared. So you could enter it exactly the way I've shown you here. I'll just clean it up slightly. Just this could help for entering it. 54x to the 5th natural log of x minus 9x to the 5th. One of those x's cancel. And on the bottom, just be very careful that natural log of x really, you've got the right parentheses. The 2 is on the outside there.
Oh, okay.
For that.
Okay, sure.
It looks like I skipped some. So let me go back and grab those.
Skip questions?
Yeah, like there's
no.
Really?
Yeah, you've been doing 1, 2, 3, 4. We're on 5, and then we have just 6 through 9 left.
Okay.
So you're good, but let me just get the bottom here. L natural log of x squared. Okay.
Okay, so what I'm seeing next is this one, differentiate f of x equals natural log of 9x. See, I show it coming up as being after this other one, 5 to the 8x plus 7.
Differentiate. Oh,
There's a couple here.
okay, let's start. Sorry, can you just go up to the beginning to like question 2?
Yes. This is the first question we worked through. Is that okay?
Yeah, that one's 2e 4x. Yeah. Second one's good. Yeah, third is good. Yeah, that one's good. And then this one, I see.
This one might be like 8. I don't know.
Okay, so that's the only one I got messed up on, but
Okay. Is it okay if I do this one, differentiate, or do you have one that you want me to do next? Like, what do you see as the next problem on your list?
sorry, so that one is 5 for me. Could you just write a 5 on there for me?
For this one?
Yeah. Okay. Now let me just pause really quick because I won't be able to multitask, and I do want to pay attention. Okay, scroll up to the previous one now.
What number is this?
So that one,
if you want me to
find that one. Okay. Okay, that is, yeah. Okay, now give me a sec. Sorry, I'm really sorry. Okay, you're good now. Thank you.
Okay. So on my side, just so you know, and this happens with pictures, some of them come in as like attachments where I can actually scroll through them. And for some reason, some of them merge together. And the issue is really on Google's side. And just as a short aside, one time I had a student book a lesson and Google put on my calendar flight information. And I thought it was from the student, which is really weird. But what they actually did is their AI grabbed some information in the booking email that they thought was flight information, and it matched up with something unbelievably on that day. And they're trying to like figure out what you want to do. So we can blame Google for our problems if we want.
Sure, that's probably operator error. Let's be honest. And that's implying me, not you.
But let's go through this problem next, unless you have one that you want. This is a good order for us. That's okay.
Sure.
Okay, so this is really natural log of u, and u is 9x, and this is another chain rule problem. So the derivative of natural log of u is 1 over u, but then you multiply by the derivative of the inside function. That's the chain rule part. So you need the derivative of 9x, because that's going to help you to figure out this chain rule. You already know u. The derivative of 9x is 9. So this derivative becomes 1 over 9x times 9, and you're just filling in, u and u prime. And this is obviously 9 over 9x. The 9's cancel, and it's 1 over x. So that's your final answer here.
Okay.
And some books, some courses, they actually go to the extent of always telling you this natural log of c times x becomes 1 over x. But it's better. I think it's better to just learn the derivative and work, let it work it out as you need to. There's a line where you want to say, okay, I'm not going to learn that rule. I'll learn, the general ones and go from there.
I gotcha.
All right. So this is the next question that I see in the email.
Okay.
And if you wanted me to tell you, if you tell me which number it is, I'll write that part in.
Yeah, that one is 6.
6. Good. So this is like the last one. It's natural log of u equals 4 minus 5x. And again, the derivative is 1 over u times u prime. So we're writing out the rule. And then we're just filling in u prime is derivative of 4 is 0. The derivative of minus 5x is minus 5. So it's just minus 5. So this becomes 1 over 4 minus 5x times minus 5. And so for there's no cancellations with the top and bottom because the bottom is actually in parentheses. So you'd write minus 5 over 4 minus 5x like that. And that's your final answer on this one.
Okay, got it.
And I guess there's kind of one more that's exactly like it. You got the picker, the question picker didn't give you much variation here.
That's okay.
Yeah. All right. So this one, again, it's y equals natural log of u. I don't know what number this is. Maybe it's 7.
7. Yeah.
Okay. And so your derivative is 1 over u times u prime. Your u is the inside function. U's are the u substitution are generally inside parentheses, exponents, under square roots, denominators, things like that. Your u prime derivative of a constant is 0. Minus 7 times x, it's just the constant out in front. So your u prime is minus 7. So you've got 1 over 3 minus 7x times minus 7, which becomes minus 7 over 3 minus 7x. So that answer will work. Now, if this were a multiple choice test, what they might do is they might actually move this negative down to the bottom. And you might say, well, why would they do that? Because when it distributes in, you get positive 7x minus 3 on the bottom. And what I'm writing now, these are exactly the same, but the one on the left is considered like pretty, math pretty, whereas the one on the right's ugly, math ugly, we'll say. That's just a small little thing.
Huh. Okay. You think I should do the pretty way, probably?
No, it doesn't matter. It will accept both. It will accept both. It's more just for like your maybe you would appreciate that. Like even in math, they do care about the look of things, even though most math professors probably don't give off the right self-image. So,
that's hilarious.
Yeah.
Okay.
Okay, and this looks like number 9.
Mm-hmm.
Okay, so this is log, not natural log. There used to be, if you talk to, it's harder and harder, but if you were to talk to an engineer that's over a certain age, they would not know why you used ln. Ln's kind of a more of a modern, believe it or not. Yeah, and so they're used to there's only log. Ln is really log base e, but it's used so often in courses and for shorthand, like it's more widely adopted, but they're essentially the same. And the tables, there's tables for each that they used to use, but now we just use a calculator, of course. So this is really y equals log, and the base is important. It's not written, but the base is 10. So if the base isn't written, it is log base 10. Like if you ever look at a stock chart over, like they sometimes use logarithmic tables or log base 10 tables because you can see what's going on over a longer period of time.
Mm-hmm.
Of u. and our u is 9x. So the derivative of this one over here is 1 over u, just like you saw before. Natural log, though, of 10, it actually ends up being whatever the base is. So if it were base 2, it'd be 2 in parentheses. But since we only have this one, we'll just do it this way, times u prime. Okay, so it's very similar to the ones we've been doing that were 1 over u prime. It's just this added little wrinkle of natural log of 10 on the bottom.
Yeah.
Our u prime is 9. And so now we just start putting those values back in. So it's 9x natural log of 10 in the bottom. 1 times 9 becomes 9. Those 9s cancel, and you get 1 over x natural log of 10 as your final answer.
Okay. Sweet.
Is that all the questions that you
Yeah.
need help with today? All right, let me stop.
Yeah, this week is